chapter 8-5, adding and subtracting rational expressions. Our learning objective is to add and subtract rational expressions. And if you remember from yesterday, rational expressions are fractions. And just like in the 5th grade, with fractions, we have to find common denominators. And step number 1 to finding a common denominator is to find the least common multiple. So we're going to go over finding the least common multiple, and that's going to lead us into common denominators, so you guys know where we're going. All right, so problem number 1 is finding the least common multiple. We're going to get a question like, what is the least common multiple of 12x squared y, parenthesis, x squared plus 2x plus 1, and 18xy to the third, parenthesis, x squared plus 5x plus 4. I see factoring in our future. Okay, so do not write step number 1 down. I'm just saying, step number 1, find the prime factors of each expression. Since this is all pre-written, I'll highlight what you guys should write down. So let me start by highlighting this. We jumped. We jumped up. We jumped. And it was frightening for just a moment. Okay, so find the prime factors of each expression. So if we take our first guy here, 12x squared y, x squared plus 2x plus 1, we know that 12 breaks down into 2 squared times 3, x squared, y is just x squared y. And then y squared plus 2x plus 1 breaks down into x plus 1 squared. So now that guy is factored. Oops, I'm highlighting. 18xy cubed times x squared plus 5x plus 4 factors into, well, 18 breaks down into 2 times 3 squared, because 18 is 2 times 9. And we got y x to the third, so write all that down. And then x squared plus 5x plus 4 breaks down into x plus 1 times x plus 4. Our second step is to write the product of the prime factors, each raised to the greatest power that occurs in either expression. So we're going to compare the two now. I'd like to, oh, there's my scroll bar, thank you. Feel. So the least common multiple, and I like to do this comparison when it's stacked on top of each other. So both of them have a 2, both of them have a 3, both of them have 1x and 1y. So both of them have an x plus 1. So you don't have to repeat those items. I feel like I should erase this so you guys can see a little bit better. So you look at the power of 2, you say 2 squared is the biggest version of that, so 2 squared goes in my LCM. 3 to the third power, 3 to the third power. You find the biggest amounts of each one. So the least common multiple is 2 squared, 3 squared, x squared, y to the third, x plus 1 squared, and x plus 4. So it's what you would get if you multiplied them together without any repeats. Alright, so we're going to find the least common multiple of these expressions. So when we look at A, we're going to factor it out. So 2 definitely factors out of the first one. And then for the second one, what 2 numbers multiply to give you -6 and add to give you -1? Well, I'll give you a hint. One of them is probably going to be plus 2. So that would be -3 and plus 2. So then I would want to find the multiples without repeating. So I've got a times 2, I've got an x plus 2, and I've got an x minus 3. That's my least common multiple. All right, let's do B together. B is, oh, that's a long one. Okay, so we're going to take each individual pieces of it. So if I have x squared plus 3x minus 4, let's factor that guy out. What 2 numbers multiply to give us -4? Add to give us 3. I know that's -1 plus 4. The second one, x squared plus 2x minus 8. Factors, which 2 numbers multiply to give us -8 and add to give us 2? That's 2 and 4, and the 4 has to be positive. The 2 is negative. And last but not leastly, x squared minus 4x plus 4. Which 2 numbers multiply to give us +4 and add to give us -4? That'd be -2 and -2. And I'm going to rewrite this as -2 squared. Alright, so we have, when we combine all these together, we have an x minus 1. We have an x plus 4 to the 1 power. And that's the same one as here, so we already have it. We don't need to write it again. We have an x minus 2. But here we have an x minus 2 squared. Because that's 1 more power up, we are going to have to write it as the square. Alright, so the least common multiple of the denominators of 2 rational expressions is also the least common denominator of the rational expressions. You can use LCD to add or subtract the expressions. Remember, when we're adding or subtracting fractions, you have to have the same denominator. So our goal is to find common denominators. Now, if you go rogue and don't find the least common multiple, but you just multiply the denominators together to get common denominators, I'm happy with that. You'll still get the same answer. You'll just have more simplification work to do at the end. So it's 6 of one and half a dozen of the other. So, for example, if you have 1/8 plus 1/10, that's 1 over 2 cubed plus 1 over 2 times 5. You look and compare. This one has 2 to the 3 power. So to make 1/10 have the same items as 1/8, I'm going to have to give it 2 more 2's, which I do here. 2 squared over 2 squared. And the reason we do top and bottom is so that we're multiplying by 1. If we multiply by 1, we are safe and it is okay. If we multiply by anything else, we're changing the value and it's not the same expression. So we're going to multiply this 1/10 by 2 squared over 2 squared. And to make the 1/8 look like 1/10, we notice that this has an extra 5 right here. So we're going to give it a 5 over 5. When we do that, we get 5 over 40 plus 4 over 40, and that gives us 9/40. So adding or subtracting, we need to find a common denominator, then we can proceed. All right, so I actually want you to write this down. Problem number 2. What is the sum of two rational expressions in simplest form? State any restrictions on the variable. X over x minus 1 plus 2x minus 1 over x squared minus 3x plus 2. Okay, so the first thing that we do is factor the denominator, so follow the magic highlighter. Thankfully, x over x minus 1 stays the same, but 2x minus 1 stays, and then our bottom denominator factors into x minus 1 and x minus 2. I like this. Always go to factor. Whenever you're lost in rational expression land, please factor first. Sometimes just factoring it gives you a clearer idea of where you want to go. This looks kind of small. All right, we need the least common denominator. If you look at this guy here, he's got an x minus 1. This guy has an x minus 1. This guy has an x minus 2. And this guy's all jelly. He's like, I want an x minus 2 as well. So we're like, okay, you can have it. I'm going to give you an x minus 2 over x minus 2. And then you can see the denominators are the same. So when you FOIL out, when you multiply this numerator, x times x minus 2, you get x squared minus 2x. And then you get same denominators. Yay! So once you have the same denominators, let me highlight so that you guys know to write it. So write this. And then we got simplify, same denominators. Yay! All right, and then you just add the top components together. So I have this x squared. He doesn't have any other x squareds on top to combine with, so he just stays. I have my negative 2x plus 2x, which they've written here, and I have my minus 1, and it's all over the same denominator. Now, the 2x cancel, and I get x squared minus 1, and my common denominator is x minus 1 over x minus 2. Then I factor x squared minus 1, x minus 1 times x plus 1, and you see your x minus 1s cancel. So at the end of the day, your answer is x minus 1 over x minus 2, and why cannot x equal 1? So, all right, so our restriction here is x cannot equal 1 because prior to canceling out x minus 1 over x minus 1 and letting it equal 1, we have to take into consideration that if x were 1, it would make that denominator 0. We're going to add in for our final answer, we add in that x can also not equal 2. Since that would also make the denominator 0. All right, so let's practice this. Let's find the sum of two rational expressions in simplest form and state any restrictions, just like we did before. So the first thing we have to do is factor, and our first guy is all the way factor, yay! But our second guy, he needs an x factored out. So if you compare the two denominators, they both have an x plus 1, or sorry, they both have an x minus 1, and it looks like this guy is just missing an x. So we are fair and equitable here. So we're going to give this first equation an x over x, and then yay, we're safeties. So the top becomes x squared plus x and the second one just stays the same because he doesn't have anything that the other guy doesn't already have. And now we're going to combine denominators, so we're going to put it over a common denominator, yay. And we're going to say that's x squared plus x minus 2. And oh yeah, we're going to factor that top guy. He's going to be x plus 2x minus 1 over x times x minus 1. And I'm going to state before I cancel, I'm going to state my restrictions. For this denominator, x cannot equal 0 or 1. So I'm going to state my restrictions first, and now we can cancel x minus 1 and x minus 1, and then we get x plus 2 over x. State any restrictions on there? Okay, and check. All right, we have two more examples. One is finding the difference. The last problem we found the sum. This problem we're going to find the difference. And then we're going to apply common denominators to complex fractions. So we're going to do, let's do B. Last time we did A. So let's factor both of these items out. So we want what multiplies to give us 5 and adds to give us 6. That would be 5 and 1. And we want a common denominator, so we have to say this guy has an x plus 5, this guy has an x plus 5, this guy has an x plus 1, and this guy doesn't. So we don't want to make him upset. We want everybody to be happy. So we're giving this an x plus 1 to the top and to the bottom. So when we do that, we get x plus 1 times x plus 5. This guy becomes x squared and minus x plus minus 1. The plus x and the minus x cancel each other out, and I get the difference of squares. I think we talked about previously. Okay, so one thing to be careful about when you have subtraction, make sure you minus parenthesis everything that is behind the subtraction. So x squared minus 1 minus the quantity x plus 3. Because when you distribute out that negative, it's actually x squared minus 1 minus x minus 3. So it applies to everything in there. Let's simplify that, and I get x squared minus x minus 4. And I think we're stating our restrictions. We definitely don't want x equal to -1 or to -5. So because there are no two numbers that multiply to give us -4 and add to give us -1, we cannot simplify this further. So we just write it like that. It includes our restrictions. All right, we're going to do both of these problems. So a complex fraction is a rational expression that has at least one fraction in its numerator or denominator or both. So now we're getting crazy all up in here. Let's look at some examples. X over the quantity 1 over x plus 1 over y. And we're going to make a simpler form of the complex fraction by taking our denominator, finding a common denominator, and multiplying by the reciprocal, trying to make it one simple fraction. So if I look here, I need to give this guy a y over y and this guy an x over x. And if I do, this becomes y over xy plus x over xy. Then this becomes x over, I'm going to combine this on my common denominator, x plus y over xy. And then remember, when we divide by a fraction, that's the same as multiplying by a reciprocal. So that's x times the reciprocal of this guy. So that's xy over y plus x. This is the same as x over 1. So the answer to this is x squared y over y plus x. All right, let's do B together and see where that takes us. I'm going to do each of these items together. Common denominator here, I need to give an x plus 1 to this side and an x to this side. So I end up with x squared minus 2x plus x minus 2 over x times x plus 1. And that the second item becomes 2x over x plus 1. Then I combine all this together. I have an x squared out front. I have minus 2x plus 1x is negative x, plus 2 more x's is 1x. And I have a minus 2. All over x times x plus 1. Let's do it. Let's factor that. factors to x plus 2, x minus 1, all over x times x plus 1. Okay, so now let's take this. To make a common denominator, I need to give this one an x minus 1. I need to give this one an x plus 1. And when I do distribute out that 3, I get 3x plus 3 over x plus 1, x minus 1, minus the quantity, x minus 1 over x plus 1, x minus 1. All right, so I'm going to write this. I'm going to combine. And remember, this negative applies to the x and to the minus 1. So it's all going to be over x plus 1, x minus 1. And on top, I'm going to have 3x minus x, that's 2x. And I'm going to have 3 minus a negative 1. 3 minus negative 1 is the same as 3 plus 1. So 3 plus 1 is 4. And I would be irresponsible if I did not factor out that 2 and write it like this. I know it's an extra step. So now I have my denominator with a common denominator and my numerator with a common denominator. I'm going to push them all back together. No, I'm going to make more room. All right, so I'm going to take my green guy. And I'm going to put him over my blue guy. And then I'm going to rewrite him because dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to have my x plus 2, x minus 1 over x times x plus 1 times the reciprocal, which means I'll have 2 times x plus 2 on the bottom. And I'll have x plus 1, x minus 1. And before I get all crazy and start canceling things out, let's do our restrictions. So I know x cannot equal 0, negative 1, negative 2. I'm also going to say positive 1 because I did have a denominator here. Any denominator, you have to exclude those options. So 0, negative 1, negative 2, and positive 1. All right, so now we can cancel. Let's go cancel crazy. I have an x plus 2 here and an x plus 2 here. I have an x plus 1 here and an x plus 1 here. At the end of the day, I have an x minus 1 to the second power over 2x. Yay, start factory. I know it's long.